Welcome to the September 16th community call for Dapper. Glad to have you on board. We have a few things on the agenda we're excited to show you. So Jeroen Schneider is going to show a couple of features that are coming up at the 0.11 release of Dapper that's due by the end of the month. It's the declarative PubSub subscription, which has been a request from the community, as well as service invocation across namespaces. And I believe he's going to show that on Kubernetes. Then Daria is going to show us a sample that she contributed to the Dapper samples repo, which is really kind of like a really nice sized sample with a real world case scenario, which I'm excited for her to share with us. And finally, Artur is going to show some of the tracing capabilities using the Java SDK. So with that, as always, by the way, feel free to ask questions in the chat window. We'll be looking at that. And we're going to have a Q&A at the end as well. So if you only think of questions later on, that's also okay. I believe this time we'll have a good chunk of time for questions. So Jeroen, with that, I'll kind of kick it over to you.
Thank you. Let me share my screen. And let me know when you can see it.
We see it.
All right, great. So Dapr PubSub, for those of you who know it and those who don't, today Dapr has a PubSub model where it can deliver events into your application using a publish and subscribe model. So in order to subscribe to topics, the only thing that you need to do as a developer is to open up a web server inside your application and have an endpoint just like this one. So this is a Node.js example, and we see that we have the Dapr subscribe endpoint. And once Dapr loads, it'll call into your application. You basically just return this list of JSON structures here, basically telling Dapr which PubSub component to use. So Dapr supports multiple PubSub components. You can use, for example, Redis, or you can use Nats. So if I had a Nats component, this would tell Dapr, hey, register to topic A from Nats and deliver it to route A. And this is the route that we're listening on to get the events delivered from Dapr inside our application. So this is nice, but it has a few limitations to it. Well, first of all, we're sort of doing subscriptions inside our code. And basically, that might limit us. For example, if we have applications that we want to start sending events to, but we can't necessarily or don't want to change their code and redeploy them. Second thing, whenever we want to add or remove subscriptions, we need to do it in our code, and then we need to build our image, build the code, redeploy to the cluster, and that might become a little bit cumbersome. And also, you can tell me that you don't immediately feel better if I just do this, right? Look at how the code looks so nice now, as opposed to this. So we've been getting asks for declarative subscriptions, which allow developers to specify in YAML form the very same type of struct that we can see here. So we introduced in 0.11, which is the version that's going to come out, this type of Dapr resource, which is called a subscription. Now, this works for both Kubernetes and self-hosted. I'm going to show it on Kubernetes, but if you look at our how-tos, we specify very clearly about how to run this self-hosted as well. Basically, you just take this YAML file here and you put it as part of your components directory, and that's basically it. So we have a subscription, and it has a name. The name is meaningless in this case, and it has a spec. So the spec here is exactly what you would see here if we were subscribing through code. So we're basically telling Dapr, hey, send all the messages coming out on the A topic from a PubSub component named PubSub to route A. And I want the subscription to only be available for applications with the ID of node subscriber. So for those of you who do not know, Dapr has the concept of a unique ID per application. So this is how we can control which subscriptions go to which apps or are used by which apps in our cluster. So this is pretty powerful. So I have a Docker image that I already built with this version of the code. And what I'm going to do now is first do kubectl get components. Let me just zoom in a bit. And we can see we have the PubSub component here. Yeah, and I'm going to do kubectl get subscriptions now. So this is going to show all the subscriptions that I have, and we can see I don't have a subscription, so I'm just going to apply this subscription here. And we can see that we have the event subscription. And now the only thing that's left to do really is to deploy the subscriber. So I'm going to deploy the node subscriber, and this is just a regular Kubernetes deployment. Just a deployment that has the Dapr annotations telling Dapr to inject the sidecar, and it's using the custom version of the sample, this quick start sample, your own 2 node subscriber, which you can find and reverse engineer on Docker Hub if you want to. So we'll wait until the pod is up and running, but it should already be up and running. And yeah, we can see that it's up there. And now I have something called a React form. So this is an application, a web UI really, that I'll use to publish messages for my subscriber. So I'll move on to this, and I'll do a port forward for React. And if I go to my local browser here, I can start sending message, well, hello there. And we'll send it to topic A, which is the topic we subscribe to. And we will submit it. And if we go back here and we take the pod, we can take a look at the logs of our application. And we can see that we received the message. So this is basically codeless subscriptions. So now you can take existing applications and just start pumping events to them without changing their code. And this can be declaratively managed. If you're running this in self-hosted mode, you will take this subscription here and you will just add it to your components folder. And so this really supports any platform that Dapper can run on. Back to you, Ori.
So I believe you are presenting the next topic as well, which is the cross namespace service invocation. So let's stay with you, Yaron.
Okay, yeah, so I'll share again. Okay. Tell me if you can see my screen. Should be able to, right?
Yeah, we see it.
All right, great. So if you've been using Dapper service invocation up until now, Dapper only supported service invocation within the same namespace. Now we support service invocation from one namespace to another. So what I have here is the Hello Kubernetes sample, and we have a Node.js application here, really simple, that gets requests to post a new order, and we have a Python application that talks to that Node application, and it's just sending it a message using the Dapper service invocation building block, which gives you a resilient endpoint to basically reverse proxy calls from HTTP to gRPC, from gRPC to gRPC, and from gRPC to HTTP, and do all these bridges between protocols, including retries and encrypted traffic and all those stuff. So here we're calling, the Python app is calling its local Dapper endpoint. And what's new here is that we can say, hey, call the Node app ID, which I'm basically defining, in this case on Kubernetes, with the annotation on my pod here. I have Node app. So the Python application is telling its own local Dapper sidecar, invoke Node app on the default namespace. So that wasn't possible until 0.11. So let's see how that works. I basically have a Node app that's sitting here, and it shouldn't really display anything. So I think it's Node, yeah, and it's just listening on port 3000. And
Yaron, maybe before you move too much into this, there's actually a good question. We might want to address this point. George is asking if you can define a namespace. I think it would be good to kind of remind folks what a namespace is in the Dapper terminology, maybe how it relates also to other namespaces like in Kubernetes.
okay, yeah. So Dapper has the concept of a namespace, which really allows you to assign the namespace per Dapper instance. So you can do it on self-hosted mode, and you can do it on Kubernetes too. When Dapper is running on Kubernetes, it basically inherits all the characteristics of a Kubernetes namespace. So in Kubernetes, you can separate pods and containers and components to run in separate namespaces, where you can assign different resources to the namespace and different RBAC permissions. So in this case, I have my node application, this application running in the default namespace, and I'm going to be deploying the Python application into a different namespace. So if you're calling from one app to another, you basically need to mention the namespace, because you can have two applications with the same ID running inside different namespaces, for example. And so this is basically the concept of a namespace. And also Dapper components are scoped per namespace. So for example, if you have a Redis state store, you can define one Redis state store for one namespace and a different Redis state store with different credentials to a different namespace, and only Dapper applications that are within the same namespace as the components will be able to use it. Okay, and this is also true for self-hosted mode. So if you look at our docs and you search for them, we have the concept of scopes. Scopes can be namespaced, and again, like Dapper brings this thing not only to Kubernetes, but also to self-hosted mode. You can assign a namespace to a Dapper process using an environment variable, in which case you can define a scope and a component that says this component can only be loaded and used by a Dapper instance that's running in this namespace. When Dapper itself is running in Kubernetes, it'll automatically sort of manage itself to know which namespace the operator deployed the Dapper instance into, and it'll hook up the namespace automatically for you. In self-hosted mode, you can tell Dapper the namespace using the environment variable I mentioned. This is all in our docs. If you search for scopes and namespaces in our docs, you will find it. It's under the concepts and how-to section. So we have the Python application here, and we can see that we're deploying it into the dev namespace. So what I'm going to do here is just apply the Python app. No, sorry, I'm in the wrong window. I'm in PubSub. I'll go to Hello Kubernetes, and I will apply the Python app, and it's been created. So it's in the dev namespace, and if I look at the logs for my node subscriber, not node subscriber, node app. We can see that we're getting messages, and this looks extremely simple. And you might be asking yourself, hey, why didn't Dapper have this from day one? And you'd probably be right in asking that. We should have had this from day one, but this actually enables a much cooler scenario, which I want to talk about. So having Dapper be able to reverse proxy calls between namespaces opens up the ability to overcome an inherent limitation in Kubernetes itself. And let's talk about this. So if you're using just Kubernetes and you had, an ingress component, which is a router or load balancer that does TLS termination for you, like Nginx or Traffic or HA proxy, and you wanted to send traffic from the namespace that the ingress controller is installed in to your backend, which might sit in different namespace. Kubernetes today has a limitation where ingress rules cannot target services from a namespace that's different from the actual ingress controller. So your application sort of need to be coupled into the same namespace that you deploy Nginx or Traffic or HA proxy into. And there's a Kubernetes issue about that. It was closed as a design decision, but still a lot of people are pretty grumbled about this, and I can understand. So that's because this is the Kubernetes ingress rule. This is what you'd normally write if you wanted to use something like Nginx and have any request coming into the /test path here target a Kubernetes service that might represent your app called test, on port 80, right? So if you see here, this service has to be in the same namespace as the ingress component. So that type of thing just won't be possible. Now, there are many reasons why you would want to put your actual backend services in different namespace. You might have different developers or actually operators or DevOps people in your organization controlling the resources and allocations to the namespaces. You might want to have, a QA namespace where you can do like canary traffic that goes through to different namespaces, and you'd want to separate them using different RBAC permissions. And there are all sorts of reasons why you'd want to do this. But now with Dapr supporting cross namespaces, that's actually doable. Because if you Dapperize your ingress controller, and there's good blog post, which I'm going to show you, that was written about how to do this, you basically inject the Dapr sidecar into your ingress controller pod in your namespace. And you can receive traffic here. You can use the TLS termination capabilities and all of the other rules that you're using for your ingress controller in the front-end namespace here. The traffic will be forwarded into the Dapr sidecar, and Dapr will initiate the cross namespace call using its native mutual TLS capabilities through namespaces. So you can actually achieve this now with Dapr. And I mentioned there's a good blog post about this. So if you search or Google this cool blog post written by Carlos, Kubernetes Nginx Ingress Controller with Dapr, it's pretty simple. It's very short, tells you how to do this. And then if you use service invocation and you call your app using what I've shown below, the app name dot the namespace, then you can essentially forward traffic to apps sitting in different namespaces with Ingress. And that's it. So back to you again, Ori.
Great, thank you, Yaron. This is great. And just as a reminder, both this and the declarative PubSub, those features are not yet available in the recent release, 0.10. They're going to be part of the upcoming release. So Yaron was kind of showing stuff from the master branch right now. So if you're looking to use that, you can just wait for the next release, which is due in a couple of weeks. Great. Any more questions on these? Feel free to drop them in the chat. If not, I'll turn it over to Daria that's going to talk about a pretty comprehensive sample. She contributed to the samples app, and Thiago as well, who also worked with her.
Yeah, I hope you can hear me.
Yeah.
Just wanted to set the context here. Daria and I work with enterprise customers hands-on in their projects, and as part of that, we identify recurring architectures or technical solution scenarios. One of these scenarios we noticed across a few enterprise projects is when multiple files like flat files or CSVs containing product catalogs or purchase orders arrive in a cloud storage endpoint, and then together they form a batch that needs to be processed together once all files for that batch have arrived. So we thought about how would we implement this with Dapper for future projects, and that turned into this end-to-end sample that Daria will present about, showing how she took advantage of many of the features that Dapper provides. So with that, Daria, please take it away. Thank you.
Thank you, Thiago. So let me share my screen. Can you see it?
You see it, yeah.
All right, let me open up my notes. So I'll walk you through this scenario one more time. So our enterprise receives sales orders from, please ignore this grayed out part. We will be focusing on this blue part. So our enterprise receives sales orders from distributors via CSV files. And these files come in batches. Each batch is made up of 3 files, each with different information about orders. And here's an example of a batch. Files from the same batch have the same prefix. And these files can arrive at different times and in any order. So we need to wait until all files for the same batch arrive before processing them. And the processing consists of combining the content of those 3 files and producing 1 JSON per order, and then storing each order into a data store. And now let me show you the diagram of the solution. So in this sample solution, we used Dapr and Azure services. And here we have a blob storage that receives CSV files from distributors. And here we have a batch generator, which is a node application that actually sends those files simulating our distributors. And as soon as a new file arrives into the storage, event grid is going to call this batch receiver, which is a node application running in Kubernetes. And what it does is it stores the names of the files into a state store using batch ID as a key. Basically keeps track of what files arrived for each batch. And it uses Dapper state management with Redis to get and update the state. Once a batch has all 3 files, batch receiver will put a message into Dapper PubSub using service bus as a message broker. And then there is a separate service batch processor, which is subscribed to receive messages for this topic. And when the message is received, it will fetch those files from the storage, transform them into an array of JSON orders, and store each order into Cosmos DB. And it uses Dapper's DB output binding to store the data. And this microservice is also scaled using Kata based on the number of unprocessed messages in the service bus topic. And also this sample uses Dapper's end-to-end tracing to send tracing confirmation to application and sites. So now let's have a quick demo. So I already have my batch generator and batch receiver currently running in Kubernetes. Batch generator, it's sending the CSV files to the blob storage, and batch receiver gets notified and keeps track of those files. And as soon as we have all 3 files for a batch, it's going to put a message into PubSub. And let's go to Service Bus Explorer and check how many messages we currently have in our queue. So it's 34 messages. And now I'm going to go and run our batch processor. And one thing I want to mention is, so I'm using Kata to scale my batch processor, and I specified that I want to scale it when I have 5 messages in the queue. So I keep it small just for the demo purposes. So it should spin up multiple instances since we have more than 5 messages in our queue. So I'll go and run our batch processor. So initially we will see 1 instance is being created. but then it should create more. So we can see that now we have more instances being created. And now let's go and check the logs. The batch processor. So we can see that batch processor is receiving a batch, processing it, and adding orders to our data store. So let's take this order ID and go to Cosmos DB, and we'll check if the item was added. Okay, we can see that the order was added successfully. Great. And so one last thing I want to show you is the, also let's go to the service bus and check our queue. Now we can see that the queue size is 0, so we processed all the messages. And I also want to show you the end-to-end tracing using Dapr. So here I have already opened one of the end-to-end transactions. And here we can see how a request propagates through our microservices. So here we can see this is the call to batch receiver to notify about a blob being created. This is batch receiver is calling Dapper state URL to get and update the state. This is batch receiver calling publish URL to put a message into PubSub. And this is batch processor being called by Dapper to deliver the message. And these are the calls to the batch processor is making to store the data. And so in order to stitch this transaction together, you need to get the tracing ID from the header of your request, and then pass it along when making calls through Dapper. And this tracing ID is generated by Dapper if it's missing from the header. Otherwise, Dapper will just pass it along. And also I want to show you the sample on the repo. So this is this batch file processing sample. It was tested on the recent version. It has this diagram, and it describes all the components, and has the deployment steps. It's partially automated. It has scripts for both Windows and Linux. And there is running and observing the sample section also, which basically describes the demo that I just showed. Yeah, that's all I wanted to show you. Let me know if you have any questions.
Thank you very much, Daria. This is a great sample. I'm really impressed, by the way, with a lot of the deployment steps that were automated. I ran myself the other day, and I think it's a really nice kind of comprehensive example of using Dapper. A lot of our samples are kind of trying to show specific things, so they have maybe 1 or 2 or 3 microservices running. And this is like really a real world scenario that's using multiple features in Dapper, showing the tracing and all that. The cool thing is that if you want to run it yourself, it's available. And I think Dara made all the effort that she can to make it easy or streamline the deployment of it, even though it can be a little complicated because there are a lot of moving parts, but I think that's the point. So I love that we have this kind of samples as well now. And I dropped the link as well in the chat window, so you can click on it. but as Daria just showed, you can just find it in Dapper, in the Dapper organization samples repo.
Thank you.
If there are any questions on this, lots of really thumbs up and stuff in the chat window, which is great. If not, I'll kick it over to Archer to talk about tracing in the Java SDK.
Hi, can everybody hear me?
Yes, we can hear you.
Okay, let me share my screen. So I won't show a huge demo like we just saw. Okay, so sorry for that. Going to be simpler. So it's basically a new feature on the Java SDK. So I don't know if we have many Java developers here in the call today. Usually we do tracing when you're doing your code. You have to instrument with some type of SDK. And now the Java SDK will propagate the headers properly for your tracing headers, just like you saw the demo. We saw the demo before, but this is only for Java. So you have an example here in the Java SDK where you follow the usual setup, where you have the CLI installation, the JDK, Maven, and Redis configured. Once you initialize Dapr, you're going to have Zipkins running by default. Okay, that's a default behavior when you initialize Dapr locally. And then we have our demo. So the code is basically a very simple service that's going to start up in the main function. And there's a controller that receives a request. And as you can see, there is no instrumentation happening here on the server side, okay? So everything is done by the SDK. If you want to customize, have more spans set up, you can do it on your code. But the Dapper native span will also be done for you automatically. So the code is very simple. It doesn't look like different from any other sample you have. And then we have two functions. One that was echo that we just saw. We're just going to echo something on the screen. And one is sleep, and they're going to just sleep for a second. That is to emulate some type of slow operation. And then you can run the service side by this command, okay? And this running the service is not really making any call. So we're going to run this on our terminal. And using version 0.10. Okay, so we already have some tracing emitted here because Dapper invokes /config on the startup. So you're already going to see some tracing right away because of this, okay? And then there's the client. And the client, you can see how now we have some tracing. So you're using the OpenTelemetry SDK, and that's the recommendation for people to use tracing with the Java SDK for Dapper. We create a scope with a span, and every call within here that happens in Dapper will be embedded in this parent span. Okay, and this is very important for us to see how those calls stack together. And if your application has other levels of abstraction, and they want to create more spans above this, you're free to do so. In this example, you only have one. So you're going to have, for every message, we're going to have a span, and we're going to make two calls. One to echo that message on the server side, and another one to sleep for a second. And you're going to see how those show up on Zipkin. And then we print done, and we're done with, and we close the span and shut down the process, okay? So it's a very simple example. Now we're going to run this on our terminal. We're going to make two messages. Give me a second. Let me just move these around. Now we're going to go to the client side. One message emitted, second message emitted, and you can see the message is emitted here, message 2 and message 1, okay? So, and we also have some metadata. So the metadata is also printed out. That's a recent addition. Now let's go to Zipkin and see how this looks. So if I do a query here, we're going to see this example. So if I click on this example now, you can see how we have now two messages. See, we have the main function, remember? And we made two calls. One doing echo, another one doing sleep, and the same thing for the second message. And they're all under the same parent. So this now is possible because the Java SDK now is propagating the headers. And we are doing this in both gRPC and HTTP. So by default, the Java SDK behaves using the gRPC endpoint for Dapr. And the same behavior works regardless, whatever endpoint you use behind the scenes. But right now it's transparent to the user and we're using gRPC behind the scenes, okay? So that's my short demo. If you have any Java developers with questions, let me know. Thank you very much.
Thank you, Artur. I'm not sure I'm seeing any more questions. So I think we can just open it up to the general Q&A. I know Stefan had a question that he patiently was waiting to ask. Let me unmute you because I think this is a scenario you were looking for some advice. So I believe you should be able to unmute yourself.
Can you hear me?
Yes, we hear you.
Okay, so I have a product which is accessible with the Java API, and all the inbound and outbound are written in Go, so you can't directly access Java API. How would you go about this? gRPC, you wrap your Java API in a gRPC code or something like this?
I'm sorry, can you repeat the scenario again? I'm not sure I
You have a Java API, a product with a Java API, and you want to use it inbound or outbound. And you can't write the inbound and outbound, it's written in Go, there is no possibility to access Java API. So you would write a wrapper around this with gRPC maybe?
So if you say that you have a Java app that you want to use Dapper with, right?
Yes. No. I have a Java file for an API for a product.
Okay, and then
do you need a public API for your application?
I don't understand. Let's. It's a jar file. And how to access a jar file as inbound or outbound API.
Oh, so you have a jar file and you want to make Java Dapper invoke that jar for you?
Yes.
Okay. So so first of all, if you want to run locally, the Java examples, they all have a jar. And so you pass the command line, and in the end, you do Java jar and the jar you want. But that would just start the Java app for you. Now, if you want to change your app to use Dapper, you need to change the code to make use of the Java SDK. Now, if you want to Dapper just to invoke the app, this endpoint, as long as this jar has some kind of endpoint, maybe on port 3000, you can use the invoke features on Dapper. So does this jar offer some type of HTTP endpoint? Hello? You're muted. Oh, it does not. It does not have a HTTP endpoint. Okay. So yeah, go ahead.
I think that the question is answered. You have to invoke it manually somehow. It's not you cannot use it directly as an inbound or outbound part of this.
Yeah, Dapr communication with the app happens through HTTP or gRPC. So the app has to offer.
So you have to write a wrapper around the thing to be invocable via gRPC.
Yes.
Yes, and what Kazum in Draziri is writing is correct, I think. This is my scenario.
I would write some type of HTTP or gRPC endpoint for
yes,
that.
Of course. Yeah. I see it this way also. Thank you.
Okay, thank you.
Okay, great. I think I saw another question about tracing, which Yanbu answered in the chat about W3C with a link. Are there any other questions? I'm not seeing anything we didn't discuss. So
there's one question by Xavier.
Oh, sorry. Yeah. Can I utilize Dapr Invoke when the service I'm invoking on is also serving external requests? E.g., I have an apt-get hello, an apt-get Dapr hello. How could I do this in a secure way?
Okay, I'll take this. So you can do this in several ways. I think the best way to do this would be to open up 2 separate web servers. So Dapr basically only needs to call a local HTTP. So you can have the local web server with cores, for example, only allowing localhost calls for the Dapr hello endpoint, and then open an HTTPS endpoint for external calls, which, you know, depending on how you want to secure it, might have a TLS certificate attached to the server or any other means. It should also be noted that we have an issue to allow Dapr to invoke your application using an API token. So today you can secure the Dapr public APIs using a token header that you inject in your calls. And we have an issue open for basically doing the same thing, but in reverse. So Dapr will inject a header with a token that you give it. And so if you have an authenticated API, or if you don't want to use 2 separate web servers, you could tell Dapr to do that. That's still an open issue though. The best way to do this really would be to use 2 separate web endpoints. Ori, are you there?
Yeah, I think I'm just looking at the chat window. I think Dave had a question about updates on workflow, which I see. You just saw Mark Fussell. Mark,
yeah,
do you
so
want to?
For the Logic Apps workflow, so we're tracking, so the Logic Apps workflow is hosted in its own runtime binaries that you can install and deploy. And the Logic Apps team at Ignite next week will be sort of announcing more of their time frame of those Logic App binaries and when they're going to make them more available and work towards a GA. So you'll hear more then, and then we'll post more updates to that. But we're just tracking the release of their binaries. So we'll pull in the latest release and build it into the Logic Apps workflow, deploying Dapper workflow repo, so you can use it. Just suffice to say, to understand that, you know, Logic Apps can be hosted and run inside a hosting environment like Kubernetes, and Dapper allows you to activate. We integrate that with Dapper, so you can activate those workflows through Dapper bindings or service invocation.
Okay, great. Xavier, I see you have a few kind of follow-up questions. Let me, well, I can unmute you and we can discuss it.
Yes, fantastic. Can you hear me?
Yeah.
Okay, fantastic. I see Yaron answering parts of it already, so I'm just trying to wrap my head around it. So Yaron, so just a question, right? So if I then bind the local one on the local host part, and the external one as well, then on the external interface, how would that change for my port bindings? Because if I open two servers on the same port, then I'm going to get a conflict, no?
Yeah, but you don't have to do this on the same port. For example, when you start an ASP.NET project, it starts out two endpoints for you, one on port 5000, which is HTTP, and the other on 5001, which is HTTPS, or the other way around, I don't remember. But basically, you just give it different ports. And then you tell Dapr which port is the Dapr server using the annotation that you would already have been using to tell Dapr the port for your application.
Okay, so okay, that's just for the internal invokes. Okay, then I get it. Okay, thanks a lot.
No problem.
Great. So I'm not sure I see any other questions. Yeah, okay, just one came in from Dave. Similar questions. Are there any samples for using Docker Compose for local development instead of using CLI? Running CLI creates port conflicts with existing Redis instance as well. It requires Dapr start out of band. So we do have a Docker Compose sample in the samples repo that I believe Johnny contributed. I'm not sure though about the port stuff.
Yeah, the answer is we don't have a sample showing Docker Compose running it locally, but I can understand it's kind of more useful because you can launch each one of the apps on different ports. But I mean, you can do that with the Dapper CLI as well. So it might be useful to put together a Docker Compose sample, just how you can use it, run it locally. But it should be, if you take a look at that sample that's in the samples folder and pull it out, you should just be able to run it locally and it would work. For launching all your services locally. Yes. So yes, you can just use Docker Compose locally to run your samples.
Okay. Great. Anything else? Again, drop it to the chat window. I'm not seeing anything. Oh. I saw that there's, Richard asks, I saw that there's potentially some work on gRPC middleware. So Richard, did you see a specific issue you want to discuss or proposal or? I mean, issues around documenting that. Oh, Yaron, if you can speak to that.
Richard, do you mean about taking issues for extending the documentation for JPC Middleware?
As far as I'm aware right now, it's not present, correct? So I was wondering if that's something that's being added. Or I saw issues specifically about extracting that into the components contrib.
Oh, okay, yeah. So I don't know if we have Haishi on the call. You should go by the nickname of Quantum Algorithms. Yeah, there he is. And so yeah, we have an issue to move the gRPC middlewares into their own components. That's true. Currently, the middlewares are HTTP middlewares. And if you're already here, I really want to thank you for your PR for doing the open policy agent middleware integration with Dapper. That's really great PR.
Yeah, this is Haishi. We are in the process of moving the JPC middleware into the component contrib. So it's in parallel with the HTTP middleware.
Okay, another question from Andrew about actors. Is there anything to help with auto deactivating actor based on memory usage? Or is that left up to the process hosting the actor? As far as I know, I think it is left up to the process, but I don't know if we have Aman on the call.
Well, that's an interesting scenario. So, like today, you can tell Dapper to auto deactivate actors once a threshold of, I think it's a time duration passes by. So, Andrew, when you say memory usage, do you mean the memory usage of all of the actor instances of a given type, for example? Or to deactivate any instance of an actor which passes a certain memory threshold. So for example, if I have actors 1 and 2 and one goes above 5 megabytes, then deactivated. All the actor instances in a given process.
I think, Andrew, you can unmute if you like. You should be able to.
So
okay, I didn't know I was unmuted. Yeah, so this is something that I had gotten used to on the Orleans stuff, which I still work in. But basically, if you've got a cluster running actors across that cluster, and you want to limit how much memory any one process can use, you can set up a memory threshold, and Orleans will start deactivating the oldest actor when that threshold is hit. So not just deactivating based on age, but also other thresholds. And it could be CPU. I even think Orleans has something with CPU, but I never use that.
Okay, yeah, I mean, that can be done. So here's a question to you. Isn't that like can that become a very big service interruption in case, the runtime deactivates actors which might be used in a transaction, for example, but they reach the memory threshold?
Well, it's deactivating actors that are older than some time frame, but not as old as the just deactivate when you're stale. There's another threshold for anything older than this. Start dumping those when you've got memory pressure.
Okay. Yeah.
It's a little easier, I guess, with Orleans because they're actually part of your process, and I'm still getting used to the idea that Dapper's not really part of my process. It's over next to my process, so you might not even have easy access to how much memory I'm using.
No, that should be doable because the actor SDKs that you're using do run in your process, and they have a very clear knowledge about all of the actor instances and how much memory they're using. So this can be done on the SDKs. If you want to see this, you can open an issue and we can start taking it from there.
Okay, thanks.
No problem.
Okay, I think we're almost at time. So if there's one more question, might be able to tackle it. But if not, then as always, feel free to engage with the rest of the community on the Gitter channel, as well as on GitHub. Open issues, comment on existing issues, and PRs, of course. So I'm not seeing anything. So with that, we'll close this meeting, and our next one is in 2 weeks. As I said, I'm recording this, so this will be available in the YouTube channel. So thank you, everyone, for joining.